Day 9, and it's Friday, and I'm free of COVID. But I'm not giving up yet. I am actually going out for the first time in probably about an hour and a half. So I'm going to have to get on this. This one looks to me deceptively simple. So I'm worried. Basically, if we kind of look at this, we've got a rope of length, kind of. It's supposed to represent a rope with a head and a tail of the rope, and the head and the tail are supposed to sort of want to be no more than, well, they want to be no cells apart, so they want to be touching like this. But the head keeps getting moved around, and we're given an instruction as to how to move the head around, and the tail moves along with it according to certain rules. If it's horizontal, the tail just moves. Like if the head moves right, the tail moves right. If they're not in the same row or column, let's say if they're diagonal, then the tail will move a diagonal step to close the gap. So and our task is to essentially work out how many positions does the tail of the rope visit at least once. So to me, this looks not so difficult. And in the past, when I've said this looks not so difficult, but I don't believe it. In the past, when I've thought that, I've overcomplicated. So let's just assume this is as simple as I think it is, and then maybe we'll find out if it's not. There is one slight quirk, which is this grid is a little bit deceptive. The head moves. It starts off at a position we're going to call S here, and it can move. It moves around, but it doesn't have to stay inside the grid. It could move anywhere. So we can't really come up with a fixed grid for this because we don't know what the grid's going to be. It might go out of any grid that we gave it, and I'm pretty sure it's going to travel a fair way. So let's give it a go. So let's take this input and then try and calculate it out. See if we can come up with a good algorithm for this. So if we call this the sequence, and by the way, the sequence itself is pretty long. It's let me work out how long it is by pasting into the text editor. It's 2,000 rows, 2,000 lines. So it's pretty long. And this, okay, so one thing I said I was going to talk about today, which I may still put off actually, is what's going wrong with my reasoning to make it, one, the planning take a little bit longer than it needs to, and two, my coding not sharp enough, could be sharper rather. And one thing is I think my planning process worked with the relatively straightforward computations in the first steps. But what I'm noticing now is that the computations they require quite a few steps. And so I'm slacking on actually running through the algorithm to check that it works. And I can't run it through with code. So I've got to run it through in my head, and I get lazy if there are a lot of computations to be done, or if they're hard to visualize in some way. So I need to find some better tools for that to make that easier. There are some other things as well that I might touch on later in this video. So I need to find a better way to visualize. The better visualization tools, the better planning tools that I have, the better my planning will be, and the further I'll get without breaking my streak, or the less likely I'll be to lose. I mean, I'm going to break the streak. I'm not going to do everything in half an hour. I just won't manage it. But anyway, so firstly, I think I sort of want to plan horizontally here. There's more horizontal space. Oh, great. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's just put these dots here. so that I can, yeah. And I might actually switch away from Excalibur as well, because it's slightly troubling things now. I might try something else in future. The reason I'm using dots here is because it won't let me paste long spaces. So we're gonna start off with we're gonna have a kind of this map in theory may not be necessary. We may just want to look at it, but we are going to need a visited sort of area for the cells that have been visited and the coordinates of those cells. And I'm just going to sort of see how this pans out. So, and also a current position. We're going to need a current position. So we're going to need a current position. This is going to be the map after, just to make that clear. And this is going to be the position after. So we need a kind of null position here. Okay, fine. Would you like to copy this for me, please? Yes, thank you. So the position here is 0, 0, 0. Or let's say x0, y0. Let's call it that. And then the map itself is going to be head. Okay, we can't visualize when head and tail on top of each other. So let's say head t equals tail, both. So here we've got G at the middle of the grid. And in terms of visited, we visited x0, y0. And that, I think that's true. We visited the 0th cell. It doesn't really matter because we're going to visit it in the second one anyway. So let's say we get R4. And each time, so R4 is actually 4 moves to the right. And each one has to be modeled individually. So we can expand this to 4 R1 instructions. Which is going to balloon the number of operations. But not by that many, like 20,000 probably on average rather than 2,000. Yes, how are we going to visualize this? Let's just have let's actually not do this. And let's have this be start. Let's have this come in again. And then let's have another one. Okay, and then let's have R4. And then this one is going to have 4 steps. So let's go call it R, 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 R. And we're going to go. We're going to track both positions, tail position and the head position. Okay, so after R, the head position will be 1. Oh, that's ruined everything. The head position will be 1, and the tail position will be still the same, and the map after is going to be like this. And visited, we're going to have the same. So how did we calculate that? We essentially had like a, let's say we've got a so we've got if the head is, I think we're going to treat the same row and the same column separately, is in the same x. If head x is tail x, which is not here. So it's really is if head y is tail y, and head x if head x is greater than tail y, no, tail x, if head x is greater than tail x plus 1 is so if head x is 2 greater than tail x, which means if head x is greater than tail x plus 1, then return tail x plus 1, I think. So that move it to the right. But we're not doing that here. But if head x is less than tail x minus 1, then return tail x minus 1. Otherwise, return tail unchanged. Okay, so does this solve this step? Okay, so if head y is tail y, which it is, Well, it is. We're comparing here. If head y is tail y, which it is. If head x is greater than tail x plus 1, so if 1 is greater than 0 plus 1, which is not. If head x is less than tail x minus 1, which is not. Otherwise, return tail unchanged. So in a sense, we've kind of ticked off this rule. It's a terrible thing. Let's put a kind of green thing by it. So we've done that. Then let's move on to the next. It can just move up, down, left, and right. Yeah, 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 it can. Okay, so x is now 2. Let's apply this logic. If head y is tail y, which it is, if head x is greater than tail x plus 1, which is 2 greater than 1, yes, then return tail x plus 1. So we're going to add 1 here. And so the output picture is this. And we visited x1, y1, or y0. So we're just tracking all the positions of tail. We can store this in a set, so that'll be fine. Great. And okay, next one, it's essentially the same logic a number of times. So we can just kind of duplicate this. 3, 2, great, and then, well, I've checked this. It doesn't matter at all. Let's just avoid going through this example, which is unhelpful. So let's actually try changing this. Let's have this be R2, and then we'll have let's say left 2. That'd be interesting, actually. So it'll need to go over. Okay. Let's go left 3. I think that'll capture all the cases. Okay. So we'll start off where it was. Great. We don't know these yet. So x2, this is actually going to be 1 now, and it'll be the same as this. And so we'll end up with both of them over each other. And so we'll end up with this. Now let's try this again. Oh gosh. Zero. Actually, did I calculate that logic properly? Okay, let me try that again. Okay. Head y and tail y are the same. Is head x greater than tail x plus 1? So is 1 greater than 2? No. If head x is less than tail x minus 1, is head x less than tail x minus 1? Is 1 less than 0? No. So we've actually checked now this branch as well. Okay, and we've checked this case, and let's take a look at this case now. So is why this one's the same. Is 0, my voice is really suffering today. Is 0 greater than 1 plus 1? No. Is 0 less than tail x minus 1? Is 0 less than 0? No. In which case we stay the same. Okay. Let's try going left again. Into minus 1 here. Okay. Now, tail y, same. Is head x greater than tail x plus 1? No. Is head x less than tail x minus 1? Is minus 1 less than 0? Yes. If so, return tail x minus 1, which is 0. In which case, we're moving this way now. Okay, that's good. Let's try going up. Then again, how many different positions are we dealing with here? So we've got, they're both on the same cell. We've got this configuration. Oh gosh, okay. We've got this configuration. We've got okay, so we've got these two. We've got these two. Now all of these result in the tail being unchanged. Now we've also got and these are different. These result in or rather, tail x minus 1 this one results in tail x plus 1 this one results in tail tail y plus 1, and this one results in tail y minus 1. So we've got these, and then we've got, where can head go from here? It can go here, it can go we've got this, we've got this, we've got this, we've got this. Are there any other combinations of these? I think this is right. So this one results in actually nothing. So this is the same, this is the same, this is the same, this is the same. And then we've got this situation. We've got this situation. We've got the reversed. The reversed. And we've got, so this is the same, one row adjacent. And then we've got one column adjacent as well. Got this. We've got this. We've got this. And we've got this. Oh no, that's the repeat. We've got these combinations as well. And we can sort of so let's work this out. This one is going to be tail x minus 1. No, wait, it's going to be diagonal. Tail x minus 1 hit tail y plus 1. This one will be tail x plus 1, tail y. No, wait, this is minus 1. Tail x minus 1, tail y minus 1. Tail x plus 1, tail y plus 1. Tail x plus 1, tail y minus 1. I have no idea if this is going to help at all. I'm just kind of interested in it now. Tail x minus 1, tail y plus 1. And then these little guys here. these will be tail x plus 1, tail y minus 1. Tail x minus 1, tail y plus 1, tail x minus 1, tail y minus 1, tail x plus 1, tail y minus 1, which is actually the same as here. So these two are the same. I'm missing one here. This will actually be minus 1. Which makes it equivalent to see, I'm getting tired now. I don't think I will do the coding this evening, actually. I think I'm probably a bit tired for it, but I'll do the planning. That goes here. This is actually plus 1. And it goes here. And this one must be here. Yeah. So we've got essentially 9 different operations. We might be tempted to do the, what do they call it? Euclidean distance, but it involves a square root. So I'm not going to do that. My initial thought was, can we pattern match on the difference between the two? On some, if this was a visual field, we could pattern match on like a string. But I'm not going to do that. But we could create a hash from a set to a lambda or not even a lambda. let's look at these. So let's say we've got minus, let's say we've got 4. So the head is at 4, 1, and the tail is at 2, 1. And so we can say the difference is if we take head minus tail, it's 2, 0. This then is, let's say this would be the opposite. This would be minus 2, 0. This case would be, so let's say this is going to be constant, and this will be, let's say 3, 5, no wait, 3, 5. So 5 minus 3 being 2. And this will be same thing, reversed. There's a sort of symmetry here, which I don't know if we want to exploit or not. But we're going to come up with a grid. And we can start to fill this out. So if the difference is, no, wait, it's going to be different than this. It's going to be like this. And we need to populate this. This is the transformation. Which is actually going to be in 2, 0. Minus 2, 0 is going to be plus 1. And then x being 0 and I've messed this up, haven't I? Let's call this x and this y. So x is, it's actually going to be here. X is going to be here. Y is going to be 0. And then when x is minus 2, got here. And then when x is 0 and we've got 2, it's going to be 0 plus 1. And then when x is 0 and y is minus 2, we get this. Okay. Now let's look at these. So in this case, we've got x being, so the head, x is 0, 1, 2. And the y is 0. The tail is, let's focus on this one. The tail is, let's say 0, 0. Or rather 0, y being 1. So y is 0, tail y is 1, x is 0, tail x is 2. Okay. Difference therefore is 2 minus 0 is 2, 0 minus 1 is minus 1. And the next is plus 1 minus 1. So looking at our table, we get 2 and minus 1. So here we've got that. Then let's look at, oh, this one's going to be the same. But this one's going to have a different difference. So let's say we've got the head at 0, 0, and the tail will then be at y 2 x minus 1. So 0 minus 1 is 1. And 0 minus 2 is minus 2. And we get this output. So let's look over here and we'll look at 1 x1 x1 minus 2. So we're here. So we've got 2 minus 1 and 2. There is a sort of symmetry to that. Okay, let's keep going. Let's look at this one and then this one. And we'll put these away. We don't need this one. It's going to be this one now. Okay. So let's say head's at 0, 0. Tail, therefore, is at x2, y minus 1. Therefore, 0 minus 2 is minus 2. And 0 minus minus 1 is 1. And we're going to have minus 1 plus 1. -2 on the x and 1 here. Okay. And then this one, we'll get the same result, but a different way of getting there. So here, let's say head is 0, 0, and therefore tail is at x, 1 is -2, 0 minus 1 is -1, 0 minus -2 is 2. So -1 on the x, which is actually here. -1 on the x, 2 here. So we're looking at here. So this is really a grid of modeling what tail should do if head is far away. And we won't actually ever get, I hypothesize, this. We're not going to get anything here, or here, or here, or here. I think that this one has got to be wrong. Why would they both end up with y increasing? Okay, 0 minus 2. Yeah, see, that's wrong. I made a mistake there. This is right. And this is the situation. So this is the situation in which we've got h is at -1 minus 2. It's actually 1, 0, 1, 0, 1, 2, 3, 4. 1, 2, 3, 4. So this is this case in which head is here. Tail is 1 along. This is this case. And so in this case, tail should move -1, no, +1. No, I've got that wrong. What is this actually, this case? -1, -2. I've not actually generated that case at all. That's wrong. Yeah, see, that's out of place. What about -1 and then 2? Yeah, this one. And then the tail's got to move 1 left, 1 down. That's right. And then +1, -1. Been an hour planning this. I don't know if I'm going to post this one. Okay. So this is the case where the head is one to the left. Well, it's not the right cell. It's just not supposed to be there. So one of these is wrong. Where's the other +1, +1, -1? Here. 2 and -1. Yes. And the other one should be at 2 +1, which should be no. 2, 2 -1, 1, one on the X, -2. It should be here. 1 on the X, -2 on the Y. It should be here. Yeah. These are fine. These match the pattern. These two are the right place, I think. -1 +1, -1 +1, +1 -1, +1 -1. So in the case where we've got let's make the special H. Where the let's say the tail is at 0, 0, and the H is here. The tail should move 1 on the X, -1 on the Y. Okay, interesting. Let's keep these. And then if tail's here and head is 2 to the right, 1 up, tail should move +1, -1. Yeah, perfect, great. Okay, well, we can pretty much fill this out. So if tail is here, so, well, we know now that this is going to be 0, 0. In fact, let's stop this nonsense. Let's make a special X just in gray for the cells that we're not going to populate. Don't need anything here. Don't need anything here. We don't need anything here. We don't need anything here, or here, or here, or here, or here. We're not going to have anything here. So actually, I think I might put these in a different. Make these one of these, but have it be gray. And then if the head is here and the tail is here, we can leave this here. Or if the head's here and the tail's here, the tail's going to move -1, -1, -1, -1. Yeah, so, okay. That's going to go there. If it's here, it's going to have to move -1, same. And if it's here, it's going to have to move +1, +1. And if it's here, it's going to be the same thing. +1, +1. It's going to move to the same place. And what we're really modeling out is the position of these cells. I still don't know if this is going to be useful, but it's kind of cool. So how does how does this help us? It's starting to feel like cracking the cryptic now. Well, one way it helps us is we could put together a simple dictionary of all of these, or even a list of lists, right? We could just put together, if we take the rows, so we start off with row -2, we would say none. Let's not make that code. N -1, -1, 0, -1, +1, -1, and then we would just look up based on its position, based on the position of the head relative to the tail. Will I go out? When will I go out? If I go out at all? No, I will go out. Okay. So in terms of a plan, I think this might be quite easy now. Loop over. So it's like, we need to loop over every row. Unfurl each row to a step. Execute step. Calculate next position of tail. Add tail position to set. Keep going. Count items in set. And so for this, we're going to need a few things. So we're going to need each row. We're going to need to each row and operation. We're going to need to have a map from direction to transform or translate. I don't know. I don't know the right terms, but let's call it a transform anyway, because I like the word better. And then we want from calc difference head tail direction to transform. We want a direction. From difference to tail transform That's basically it. So in terms of a plan of action, it's what do we want to do? We want to drive from direction to head transform to drive calc difference head calc difference drive from difference to tail transform for drive main loop and that's it. Okay, I think let's see if I can give this a go. And we might get the first step done. I don't think I'll get the second step done depending on how easy it is, but let me share my VS Code. Do a bit of window management, and actually I'm going to have my plan here. Great. Okay, that's probably good enough. Okay, input. And then the trial. Okay, let's get started. Don't know why I did it that way. See, now I've done that as well. There we go. I don't even know why I wrote this. Don't need that. This is going to be plus 1x 0 left is the opposite way. Up is 0 and -1, and down is 0 plus 1. Okay. Let's hope those are the right way around. Zero minus -1 is 1. 0 minus 1 is -1. Okay. Right. Just doing this based on my diagram. Well, these could really be 0, 0, couldn't they? That's probably better for the ones that we do genuinely want to save us a bit of implementation. Okay, and we know it might be nice to align these. Since I'm so confident, stop wasting time, Kay. No, come on. I might need to get rid of these plus ones, actually. Plus one is a little dubious, isn't it? It's not, I don't know what that will do in Python. Oh, but now it's messed up all my alignment. Why am I starting from the right? Come on. Come on. There we go. Okay. All right, let's see if we can get my thing that I keep having to rewrite and not. Why do I do this to myself? Okay, don't need that. File name, yes. Don't need this, don't need this. Great. And we're looking for the, okay, visited is a set. And what we want to do is okay, line equals line trim strip split. What do they look like again? Yeah. And then we've got line 0 being the direction. So let's get head transform equals okay. Let's make this a little bit nicer. Direction equals line 0, distance equals line 1. Okay. And then for n in range 0, distance, which if it was range 0, 1, so actually -1, I think. We just want to do it 0 times for n in Oh no, actually, not -1. We want to make these in this one an integer. Don't know what this is complaining about. Okay, I've just minimized my editor. That's irritating. Okay, let me not worry about that. Getting distracted. For n in range, so head starting off at 0, 0. This could probably just, I probably could have just implemented that nicer. Okay, and then tail also starts off this. Diff 0, diff 1. And this is going to be -2. No, +2, because it'll be -2 at most. So +2 will get it to 0. Okay. Tail equals is it add? Yes. Okay. Then at the end of this, we should return the length. Okay, and then we close the file somewhere here. Great. Okay. This should be, there's a lot of ifs here, but I may have gotten various things wrong. Let's find out. Okay, list index out of range. Fine, let's look at the diff. Okay, how did we get to that? Tail isn't moving. This one should move. So the difference is, so this will be +2. So this should be 4 and then 2. But actually it needs to be 0, 1, 2, 3, 4. Yeah. So this will come out as indexing into 4 and 2. So 4 on the first So 0, 1, 2, 3, 4. And then, so actually it's the wrong way around. And then 2. Whereas actually, so what's the actual transform coming out? Zero, 1. Why isn't that being applied? I know it is being applied. So, okay, if we look at this, we're starting off at um, so we start off here. Okay, focus, focus, focus. So head moves 1 to the right. Tail is at 0, 0. The difference is, okay, so that's correctly 0. This one, the tail's 2 to the right. The difference is 2. And head minus tail, yeah. The difference is 2, therefore it should go 1 to the right, which is correct, and it does. Then head moves another 1 to the right. Oh, but it's moving on the y-axis. Yeah, it's because this is the wrong way around, I think. Actually, it's the wrong way around. Okay, so what have we actually got then? I guess it's a bit further anyway. Don't we get a result? 14. 14. Okay, weird. Why do we get 14? This is going to be time consuming. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's definitely 13. Okay. And they should all be, yeah, okay, fine. So 2 across minus 2, that's right. 3 across minus 1. 0, 1, 2, 3. Minus 1, that's wrong. 3 across minus 2, that's right. 4 across minus 3. That's right. 0, 0, that's right. 3 across minus 3, that's right. 2, 0, that's right. 1 minus 1, that's wrong. So that's 2 that are wrong. Ooh, maybe in trouble here. Let's look at what it's doing. Okay. Okay, so where do we end up after each one? That's what I want to know now. Okay, right. Yeah, that's good. Wait, no, it's not. Why is tail going? Okay, so head's here. So after the first step, head's here, tail's here. After the second step, head is at 2, 0, where it's supposed to be. This is at 1, where it should be, but -1 after the second right. That doesn't make any sense. Have I made some grievous error here? Okay, let's look at the transform as well. We're definitely getting this. Where does that come from? Oh, that's not right. God damn it. I need to get this right. Let me just check this stuff. -1, -1, -1, 0, -1, +1, -1, -1, -1, +1, -1, -1, 0, +0, -1, plus, -1, plus, 0, plus. Okay. Still 14. Save it. No more of these silly mistakes. I'm not dealing with this anymore. Okay, so 13. Now we're good. Right. Lovely. Let's get rid of this thing here. Let's go here. That's good. Now, let's try printing out the... Wish Python would flush like I would want it to. Why would I ever want that? 6642. Are we onto a winner there? Let's find out. 6642. 6642. Yes. Okay. 9:28 left. That means we were just over 10 minutes. Okay, great. So the idea works. Amazing. Let's look at this. We might not solve this today. A rope snaps. Suddenly the river is getting a lot closer to you than you remember. The bridge is still here, but some of the ropes that broke are now whipping towards whatever. Rather than 2 knots, you must simulate a rope containing 10 knots. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. Using the same series of motions as the above example, but with the knots marked H, 1, 2, 9, etc. The motions now occur as follows. You know, I think that our solution might possibly work now. Do I want to try this now? In principle, it is exactly the same problem. In principle, it's the same problem. We just got to go through each of the steps, each of the segments one by one, and update them. One by one. So it should be as simple as moving through a list of knots, of which there are 10, including the head, right? Yeah, including the head. From start to finish, or just even just hard coding in, just 10 ones. No, that'd be horrible. That'd be terrible to do that. I would hate that. Yeah, we could just loop through the current code and just change head and tail to point to different things. That wouldn't be so bad. I'm too tempted. I've got to do it. I've got to do it. I've got to do it. Okay, let me look at my code at the moment. So yeah. So we need to change the head and the tail to be a list of coordinates. Then iterate over each one, with the head being the first and the tail being the last. No, the tail being the next one down. And so we've got to go through 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, 7 and 8, 9, 7 and 8, 8 and 9, and that's it. I think I can do this. I think I can do this. I think I can do this. I don't even need a plan. Whoa, okay. Hearing myself say that. No. A novel. No, 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 no. No, okay. I do need a plan. Plan is one. Change head and tail to list of 10 knots, the coordinates. Change loop to loop over, or add inner loop to loop over chords pairing 0, 1, 0 and 1, 1 and 2, and etc. Recalc, you win. Okay, I think I'm going to do it. I'm going to do it. It's going to be great. We're going to have a great time. I planned enough. Planned enough. Yeah. Okay. So okay, I need to start a time before I start muddling around. 30 minutes. Ages. So much time. So much time. Get rid of that and find out what the answer is supposed to be for this trial. 36 positions. How many is that going to be? Well, that. And then in here, we're going to 4 not in not range 0 to length of the knot, which is going to be 0 to 10 knots. It's got to be I know there's a better way of doing that. Just don't want to organize it right now. Okay, and we'll get an error if that goes too far. And then we want to set it back at the end. Or really, we can just kind of let's just set it back at the end. Head and tail have both changed. We want to add the last after all of this, which I'm pretty sure is, yeah, great. I want to add the last one. And that should be it. But it's not. Why have I? Wait a second. Yeah, okay. So I need to get -1 here. Okay. Now we're in trouble. Why isn't it printed out? 13 still. 13 still. How many knots are we iterating over? We are going through them all. How can it still be 13? What is going on here? Okay, I'm getting confused now. Oh, come on, okay. Okay, well, that's not right, is it? Does it need to be further? No, it doesn't help at all. I didn't think it would. Okay, let's try debugging this a little deeper. Oh, oh, weird. Why are we only getting the... Okay, that's odd. It's just moving every. Can we sleep in Python just so I can see this work? Why is it on time? Okay. Oh, gosh darn it. Okay, I get it. Only head needs to move here. Yes. Okay. Gotcha. Only head needs to move there. Okay, okay. That's a silly mistake. Yeah. That shouldn't be able to happen. Yeah, that shouldn't be able to happen. Oh, no, wait. It can happen. It can happen. At which point, what needs to happen there? No, actually, that was right. Okay, so we're going the wrong way round for one. Swap that over. Okay, so yeah, we go two up. In this case, the 3 should go up, and the 4 should go up to here, and then this will happen. Should it just go a diagonal? It could just go a diagonal. At which point it could go it should move across 1 and up 1. And this should go across 1, down 1, and this one should go -1, +1, and this one should go -1, -1. Okay, will this get us further? No. No, this isn't right. No, that's not right. I don't know why it's not trying to go further. Right 4. Left 3. Oh, no, wait. It's a different set of instructions. That's bloody why. Oh, my gosh. The things they make me do. Okay, we're good. Okay, great. We're actually getting somewhere now. I think we might match it. Okay, all right. Well, we may still make it. We might still make it, you know. Okay. We should end up with 5 on the corner. And we do. Great. Now we're going left 25. It's going to take too long. I'm gonna just let it. I'm gonna turn off the sleeps. Okay, we win. We get there. It actually works. Okay, in which case, let's stop all this costly formatting. Okay, 2765. Do we win? Do we win? Please, please win. 2765, 2765. Yes. 948. Oh my gosh, I absolutely cannot believe we've done this. To paraphrase a Vine that I once saw. Wow. Okay. Well, this was an epic 2 hours. I thought this was I loved this. Really felt like I was puzzle solving when I did this bit. And you know, a few bumps in the road when it came to the second phase, but not so bad. And really well recovered, if I do say so. I mean, honestly, after this week, I deserve this. So, wow. Okay. Thank you and good night.